Hi, thank you for coming to my presentation. I'm Leila, and today we will be talking about errors. The essay begins by discussing a class of errors which are more an unfolding process or journey, or an error whose status as an error is essentially speculative. The errors are not really errors so much as they appear to be on a journey to becoming something another process remembers seeing or solving before. We identify these kind of errors by knowing of or hoping for a better alternative. But better is a consensus reachable through dialogue. Something about these errors I found deeply unsettling, and so in a previous version of this essay, I was determined to automate them. The formalism that I found resembles the relationship between a programmer and compiler, and that the program is the complement of the programmer's awareness. So whatever is indeterminate in understanding is passed on to the program text, and the compiler, in giving error messages, directs awareness to memory retrieval. The compiler is a bit like the decider of decent taste or mediocre style. So in this presentation, what I will be focusing on is something I couldn't really talk about in the essay, which is what is actually needed for the process of programming. For programmers, what is needed is a system that helps them forget or be above themselves and whatever they feel is necessary, since that could distract from the program. So for instance, questions about usefulness, ethics, personal intentions, context, practicality, profitability, logic, country, religious affiliation, language, and so on. The less programmers are aware of themselves in the process, the easier it is to participate in kind of the shared awareness of programming, or to think in terms of harmony as they're developing software. Since programmers are needed by society, these systems are kind of being provided by default, but I'm not really satisfied with the whole situation. So I will transform it into one where we remember what the computer wants us to remember, because that seems like the best move here. More than anything else, programmers need good problems to work on. We can think of a good problem as a redundancy that is neither pleasurable nor avoidable. And a redundancy can be a process, but it can also be redundant yearning. There's that Wordsworth quote, how poetry is the spontaneous overflow of powerful feelings, and I imagine a bunch of people in a town having to cross the river by swimming or rafts or canal jumping or what have you, and all of them are wishing for a better way to traverse the water, and how that becomes collectively a spontaneous overflow of powerful feelings, and the engineers design a bridge. Programmers are not really solving problems the way a bridge solves the water problem. I think of software more as refreshing a cold case of feeling, sculpting a more easily manipulable image of a forgotten or obscure problem. The type of problems that most programmers are tinkering with determines the future of the field, so hopefully they are not useless and agonizing. The trouble with problems is that it's no one's job to look for them and study them, and that's really for the best, but we will turn to the people whose job it almost is. I think this is a nice partnership with higher education. Not only would solving their problems be a great source of problems to solve computationally, it is just a nice vision of schools. All students should start in the same 1 to 2 years kind of classical program, which would be mainly focused around history to have an understanding of like what has happened before, to see that our place in the present and our ability to look back is an abstraction, and to give everyone this common knowledge base. Following that could be error-based schools where students can specialize in different subjects, like not everyone has to be a programmer. The point of this kind of approach is that people can't care about everything, but it's good for lots of people who care about one thing to be working together and building something tangible and doing research and kind of logging and archiving how they do their research and building along the way about these real problems. I see this as kind of being a job, so it's not meant to compete with certificate programs and vocational programs, and I think that there's a real danger of all of higher education going under if it tries to, like beat them, because they won't. And the last one will take too long to explain, so I'll just leave it for the Q&A, I guess. Oh, well, I guess these are kind of like the last one. I saw these in a paper that I read just yesterday when I was working on my style compiler, so it was about the process of programming, and it was about these errors at Facebook and Google earlier this year. And what's spooky is that they are abstractions that are unsolved. They're kind of our own making, which to me is a sign of how urgent it is to hold back on kind of solving things too quickly before trying to understand where it came from, since they can't trace it back with our current formalisms, and that will make future problems very difficult. The next thing that programmers need is trial and error, and this is something we really take for granted, but I think it actually is kind of very precarious, and there's so many things supporting it right now. So yeah, it's really related to reliability, which is kind of the house of all error processes, the best of all consensus, in that the process of software development is really this long, unending sequence of decisions about implementation details being good enough or not good enough. It's really the ability to evolve problems that can kind of challenge trial and error. So the notion of reliability is dependent on the ability to imagine errors before they happen, so to foresee consequences and to backtrack when something happens that wasn't expected, and an ability to remember that so in the future you can foresee it. The greatest kind of strength or support of this need is the shared language of computer science, because that kind of is a way not only to learn from other programmers and to share in their process, but for research to communicate with programmers. It's almost like talking through time. Research is kind of like programming for programmers. So we will think about how to solve this step for researchers, like how to make research reliable, process of trial and error, since that's very difficult. But first I'll just point out some kind of quick trends, which one is not really a trend, it's more just our reliance on mathematics, and that it's important to ensure it does not become a way to hide from increasingly useless abstractions, since that's something to deal with. The second is with the pop culture kind of going through its nostalgia, recycling for the same time span as computing, so that's very convenient and it keeps a nice stable context. Though it is strange how people are romanticizing the years 2014 to 2016. The third, and the one that I feel most strongly about, is how we have such a short history, and I think it's probably the only history that I can think of where we can interpret it correctly still, since because of how short it is, because of the stable context, and because of the nature of computer science with its relational language. And so I'd see the school from number one as being kind of an archival center as well. But yes, the really important thing is this people-based history. Just with abstractions, I find it's very helpful sometimes to kind of trace them back and see where two ways of thinking about a very similar concept um, split up or where they came from. And I think that kind of work is going to be too laborious very shortly. Okay, so the last of the system, although it is kind of a simultaneous motion, is payment. Payment allows you to forget what is necessary because your needs are met. But you are also creating something for someone else. My keynote keeps glitching, but essentially creation can be very draining, and regardless of whether or not you like what you are creating for someone else, it is a use of energy, imagination, enthusiasm, intuition. And so we look at computing education just being just a popular research area and what it represents, the fact that the system is kind of incentivizing it to create something basically, and how it's a very serious opportunity to have systemic change, because it's kind of a reminder that learning should be useful and it should be creative, and it is also expressing a dissatisfaction with the current supply of programmers, workers, learners, and etc. So essentially just something to consider, that yes, computing education, it is a terrifying and exciting opportunity.